today.
Can you add a bonus question?
Sure. You got it. You got it.
I could do a solid regression.
All right, here we go. So again, remember, as we're going through this, you're going to miss a bunch, right? You're going to get some right? You're going to miss some, all right? So just let's look for where some of those errors are, where we're making those mistakes. And part of this question is, do you understand notation? This says capital F of x equals this integral. This says, what is the value of capital F of e? Guys, this is nothing more than let's take e and plug it in, right? Let's take e and plug it in. So what it is it's an integral from e to 1 of natural log of x cubed of x dx, right? That's all it is. Well, we have to take that integral, right? And we did a whole bunch of ones that involved natural log. Because what is the derivative of natural log? 1 over x. And what do we have in this problem? A 1 over x. So there's my 1, right? So I'm going to do a u sub with natural log. So du equals 1 over x dx. Oops, u cubed. Right? A fairly simple one, right? So this is going to be a definite, right? This is going to be a definite integral. So a fourth of u to the fourth from e to 1. U was that. And then we just plug in our e and plug in our 1 and take our difference, right? So our final result is going to be a fourth that, right? How do I evaluate this, guys? Well, isn't this 4, can't this 4 be brought out in front? So isn't this the same as the natural log of e to the fourth? What's the natural log of e? 1, so 1 to the fourth is 1. So this is a fourth times 1. Minus, all right, what's the natural log of 1? 0, yeah. Gives me my answer of 1/4. Good? Number 2, piece of cake. Trapezoidal approximation, right? Here it gives me this discrete data, right? So remember, with discrete data, can we really do a definite integral and do it precisely? Do we actually get a perfect answer? No, the best we can do is the approximation, right? The best we can do with the discrete data. So if I was to graph this, what would it look like? Well, 2, if I really quickly graphed it, it would be that, right? Well, what could I do with this? Do you agree that I could make three trapezoids? And what is my formula for the area of a trapezoid? Base time, average of the base times the height divided by 2. Yeah, so well, the averaging does the divided by 2 part, right? Yeah, so let's see here. I have 10 and 30, so that's going to be an average of 20. right? And then how big is this first trapezoid? It's 3 in width or 3 in height, right? So I got 3 times the average of, and again, how to get the 3? 5 minus 2, right? So actually, I'll write that down for you guys. And if we do that math and get those numbers, we're gonna get 160. Good. First 2 problems, not too bad. Lexi, this is straight up. Do you understand or do you remember the mean value theorem, right? What is the mean value theorem? Well, the mean value theorem says that there is a value that exists that must be the mean value of the integral from a to b over b minus a. That's just a straight up mean value theorem definition, right? And again, think about how this works, Evan, right? What does this do? This accumulates all of the values from a to b, right? And then I divide them by the difference of b to a, and that gives me the average value on that interval, right? What is f of c? F of c is some value that must be between what? A and b, right? I mean, it just makes sense when you think about it, right? And so if you actually solve this by multiplying both sides by b minus a, we get choice A. Yep, I just literally said that what I could multiply by b minus a, right? And so now it would say FC times this equals what we were trying to solve for. Good. How about here in number 4? We want to find an integral of this. This is if you've been following along at home, this is a classic case of calc. What do you guys think? Yeah, U sub, yeah. What do you think you would use for the value of U? So 1/3 of du equals x dx, right? Oh, hang on a minute. X squared, my fault. Classic substitution, right? Bang. So there's my derivative portion, and there's my value for u, right? And so we can rewrite this as an integral cosine of u du, and we need 1/3 of that, right? Integral of cosine is sine. 1/3 sine u plus c, and u was x cubed. Which gives us choice C. All right. So first 4 guys, quite honestly, I don't think those are too bad, right? This one, how nice is this? Using the substitution, u equals. What is this equivalent to? Okay, well, if u equals this, then du equals this, and 1/2 of du equals this. Well, awesome. Can I rewrite this now as an integral from 2 to u of radical u with the half in front and a du? Choice? Hey. How we doing? What am I doing here? Finding the derivative of the integral, fundamental theorem, right? When we find the derivative of the integral, we would really love it if this was just an x, right? Because if this was just an x, we could change this to be an x and move on. Well, let's do it. But there's a problem, right? Oh, by the way, I'm also going to do this part. Actually, I don't need, sorry, hang on. I don't need the dx, do I? Minus, because I just plugged it in. So what does that give me, guys? What do I do when I have a power raised to a power? Add them, multiply them. Good. All right, so I have that. So right away, even if like I wasn't really like all that great at calculus, I'm pretty sure that I could get rid of those two. Now maybe I would choose this, right? And I would choose this if I didn't know better, because remember, with the fundamental theorem, guys, if this is differentiable, what do you need to do? Multiply by the derivative. And what is the derivative of 0, by the way? It's 0, right? So what happens to this piece anyways? It goes away, and what do we have? We have 2x sine of x to the 6th, which is choice B. Okay? Because guys, hey, pss, pss, pss. The integral of something with sine would be something with a cosine, right? But then we're taking the derivative of that, which is going to make it go back to a 1, right? I mean, even just thinking about it that way should eliminate this as a choice, right? So I could see how maybe we'd make a mistake and choose this, but we get YB's answer now? Good. Number 7. Guys, this is a perfect example. Average velocity, right? I'm asking you for an application of mean value theorem, right? I'm asking you to find an application of the mean value theorem if I want the average velocity. And what does the mean value theorem say? It says that there is a value that is going to serve as the mean value where I can take the integral from 3 to 0 over 3 minus 0, right? So a classic case of mean value theorem. Can I integrate this pretty easily? Pretty simple one, right? It's going to be a third of t cubed plus t. And we're going to integrate that from 3 to 0. All right, so if we integrate this from 3 to 0, what do I got here, guys? I got 3 cubed, which is 27. A third of 27 is 9. 9 plus 3 is 12. What happens when I plug in the 0? Yeah. And I wind up with 4. Okie dokie. Number 8. An antiderivative is kind of like a what? Kind of like an integral. This is the hardest one on this entire assignment, as far as I'm concerned. Okay. And it's because you really gotta like be on your game to see this one. Okay. And maybe there's other ways to do it, but I'm going to show you the trick. In order to do this problem, guys, I had to recall the following. The integral of Lexi, did you just say bye tomorrow? Did she just say bye tomorrow? We've been doing these, like, would that come as like a surprise? Yes, that. So, knowing this, we got a problem. This doesn't take on that form, right? Now, when I first looked at this, I said, oh boy, well, can I do this by creating a bunch of fractions? No. Can I do this as a U sub? No. So it took me a few minutes to realize, well, if I have an x squared minus 2x, that's cool. But how else could I write this? Couldn't I rewrite it like this? Now, why would I want to rewrite it like that? Well, if I rewrote it like that, couldn't I rewrite it like this? Do you see it? Now that I wrote it. So what did I do? I changed this into the sum of two squares by rewriting this 2 as a separation of 1 and 1, knowing that 1 squared is a perfect square, and that this can be factored into x minus 1 times x minus 1, which makes it a perfect square. Why did I square the 1? Like here? This just to say that now it takes on this perfect form, right? So what is the answer to this? The answer to this is tan inverse of x minus 1 over 1 plus c. So if you look at the choices, obviously what's the solution? Choice D. So why is it written without the c? Is it wrong?
It was, like C can't be any value because it's
Actually, it's actually the exact opposite reason. If I said what is the integral? The integral is what? The one thing that will always work, right? If I said what is an antiderivative, isn't this an antiderivative? Isn't this an antiderivative? Right? So this is an antiderivative. It's just not the integral. They could have. Absolutely. Absolutely. Yep. So when I say what is an antiderivative, you don't have to have the c because that would just imply that the c value is 0. Right? And that is an antiderivative, right? Make sense? Right? If I said give me some money and you give me a dime, and I said, really, that's it? And you're like, well, it's a dime, it's money, right? If I said give me the amount of money you owe me, right? Now you gotta give it to me perfectly, right? Difference, right? This is a, number 9 is I think one that's actually right out of the notes. It's a perfect U sub problem. So a half of du equals x dx, pretty straightforward. So here is my x dx. Here is my u. So what does this guy get rewritten as? It's a half of the integral 1 over u du. And what is the integral of 1 over u? It's the natural log of the absolute u plus c, which gives us choice A. Okay, guys, aside from number 8, because you know, right? You know you're going to have those questions that are going to show up, right? There's going to be those next level problems, right? Because what? Nobody gets 100 on the AP, okay? You're going to see one of those next level problems, okay? That you know you'd have to be really, really strong or really, really lucky to remember some of those things. And that's one of them. It's a tough one to see. That is a tough one to see. All right, free response. All right, numero 10. This is a straightforward, do you know the derivative and antiderivative of tangent? And that is a straightforward U sub problem, isn't it? So here is my, and here is my, and it is an integral of 1 over radical U du. Same as or which gives us how you doing? What do you guys think about number or letter B? Another U sub, right? Yeah, what are you gonna make it? E to the x. Oh, probably do this part first. How's that look? So what do we got? We got our e to the x dx. We have our value for u, right? Now, what's our issue? It's the issue is that this 3 is being added, right? You see the problem? If it was 3 e to the x, the 3 could come out in front, make it a third, right? It's actually a really, really easy fix, and this is a roadblock that I'd imagine that you could stumble upon. How can I edit this really quickly to finish the problem? I need to change my u. What do I want to change it to be? Add the 3. Yeah, because if I make it 3 plus e to the x, what's the derivative of that? It's still what? It's still e to the x, right? So now this is my value of u. And now we're in good shape, right? So again, these are the types of things that you might run into, right? And that is the same as this. And there you go. So again, quite honestly, the first couple, you guys should nail those, all right? Should nail those. I would suggest that C is the first one where you might run into a little bit of trouble. Everybody got that? Because there is something kind of weird that happens here, and you either see it or you don't. I mean, that's just kind of the truth. What would you be inclined to do? Make the bottom. So what do you want to make U? Okay. So you did that so we could take a derivative of it, and we get that, right? Okay, now you want to divide everything by 2? Like this? All right, and you're pretty smart. That's exactly what you should do. So there's this and there's this, which matches up. There's our substitution, right? And we wind up with an integral, or a half of an integral, of 1 over u cubed du. Same as this. Add 1 to the power. Put my corrector in front. Everybody agree with that corrector, negative a half? So what do I got? I got negative a fourth of that, which I'm not going to leave my answer like that, am I? I'm going to write it. I'm going to write it like that. All right, so again, you know that there's a little trickiness in that step right there, right? You either see it or you don't. Agreed? Right? Either see it or you don't. There was an algebraic technique in D that you had to use to solve it. All right. So when we look at this, again, instinct and gut tells us you sub it and make what? Yeah. I mean, that would be what I would certainly think when I look at this. Probably going to be a U sub, probably going to have to use x plus 1. And we get du equals dx. What's the issue? We can't get rid of the x, right? Until a superhero came along and said, if this is true, then that must be true, right? So that means that I can now do what? I can substitute that on the top, right? So the top of this can be rewritten as u minus 1. See it? And then we had what? We had the dx and the dx. So now I can rewrite the dx as a du. That's good news. And we said that that's my value of u, right? And now look at that. Well, great. Sure doesn't look like I made it any easier. But how many things are on the bottom of this? 1. So can I write 2 fractions? So isn't this the same as that? Which I would rewrite to make it look pretty as that. And those are 2 integrals that I can take fairly easy, right? Gives me a final answer of that. All right. Guys, what's nice about this whole first page? If you're really good at the algebra stuff, they're all pretty. They're algebra techniques, right? None of these required any memorization of identities, did they? Shouldn't say that. This one kind of did, right? Kind of had to know that one. All right. On the next 4, we got a couple identities that we got to remember, okay? And here is the first one. I showed you this one earlier, right? So for E, we need to recall the following. All right, so we need this one. Without this one, we get stuck. Now, here's the deal. Where do we get stuck? Do we get stuck right now? Oh, a little bit, because the bottom fits the bill, but the top doesn't. So it's not a U sub problem, is it? At least not in the traditional sense. So what was a technique that we used to tackle something like this? What's in this problem? Only x's, right? And numbers in terms of constants and coefficients. But what could I do with these 2 things? How I can't split it because there's how many things in the bottom? Yeah, 2. Brandon, what could I do? I could divide them, right? So if I wanted to play a little long division game, actually, I'm going to write it this way, guys. Right? So if we did this division, x squared goes into x squared once. Gives me this, right? If I subtract that, I get a -1, right? Can I put x squared into a -1? No, so this is my remainder, right? So I get that. And Evan, do you know what's super cool about that? Now I'm taking this integral right? So again, I made the division, right? So now I said I'm going to take the integral of 1 dx minus the integral of this dx. And do you see why it's happy news, happy time? Because doesn't this match this perfectly? So this matches this perfectly. That's a tan inverse integral. What's the integral of 1? Just x. Yeah, so our final solution is x minus tan inverse of u over a. Well, in this problem, guys, what do I have? Well, u and a, right? So I flipped these two around when I rewrote this problem, right? So we're going to write it as x over 1. Let's see. Good? This term right here is always going to be the variable, right? This is always going to be the variable. So the variable always goes on top. The a is always going to be your constant value. Give me something I can do with f right away. Pull the 4/5. And we get this. And again, this is, boom, what do you see in the bottom? A radical. Immediately should be thinking the following. Recall. Re-all. Okay, maybe recall. That, the integral of. I'm going to write it this way. Is that one, right? And does it take the form? It does, right? So what do we have? Well, my x squared and my x, do I have that relationship that I need to have? Yep. Am I subtracting? Yep. I know 3 is not a perfect square, but if a squared is 3, a is radical 3. Yeah, so everything's there, right? So in this case, we get a solution of 4/5 times 1 over radical 3 inverse secant. And there it is. Cool? Evan, is it cool? Do you really mean it? All right. What do you guys think? This is the second hardest problem on here, part G. Took me a few minutes to figure this one out. I had to use my trusty AP calculus eraser. I've really worn this guy out pretty good over the course of this unit. Again, this is what separates, right? Somebody who's, a strong, like breezes through this thing with a 5, all right? And somebody who's not going to be super, super strong breeze through with a 5. It's a super, super tough little algebraic technique. What would you really love to have in this problem? T to the, okay, so you're right, but let's go the other route instead of that one. T to the fourth, right? Yeah, so she was saying if this was T to the 7, that would be great because this is 8. But if we think the other route, it'd be great if this was 4, right? Well, guys, how hard is it to make it a 4? Can I make it that? Right? So now what's my value of u? It's t to the 4. So du is 4t cubed dt. Giving us that. Pretty simple substitution now, right? So when we substitute in, here's my, oops, wrong spot. There's that. There's that, right? So the way I'm going to write it now is this. So this is the same as 4, 1 over that. And if you got to that point, again, this is why I say it's, I mean, this is a high level calc problem because now we have to recall the following. This is, let me make this an a squared. Is this. Right? So again, I mean, it's a next level problem, right? So I have a final solution, right? Because this is one of the identities of 4 sine inverse of u plus c, and we had plugged in what for u? We had made u t to the 4. So our final answer is 4 sine inverse t to the 4 plus c. If you just, oh guys, I made a mistake. Hang on. Right here. Right here. What this, it shouldn't have been a 4, it should have been a what? 1/4. Sorry. This should be a 1/4. So this should be a 1/4, this should be a 1/4. All right. Guys, I'm not gonna do the last one because we're out of time, but what are you gonna do with the last one? Take 2x. No, it's not a substitution. Guys, divide it, divide it, divide it. There's one thing on the bottom, right? So it's really just the integral of 2 plus 3 over 2 is really that, right? And then just make 3 separate ones. So it's a pretty simple one. Your final answer is this.